Hi everyone. In the given problem statement of Roman to integer, we have Roman numerals which are represented by 7 different symbols. There are only 7 different symbols. So here if we look into the condition, for example, let us take this example y11, which is going to be, we have to map this one symbol. So the first initial value is going to be, we have to loop it through. So 1 would be, we can have a result value which is going to be 0. So looping it for the first time, the result is going to get incremented by +1. Similarly, the second one would be another +1, which is going to be 3. There is also one more condition, which is LV111. Now, once you loop it through, so you know the corresponding value of L is 50, corresponding value of V is 5, and corresponding value of all these ones are 1 plus 1 plus 1, which is going to be 58. So these are very straightforward. You just have to loop through the list and we are going to get and sum it up. But the problem rises when we have a value like IV, which is basically, if we have a preceding value before the current one, it means that a value got decremented. So here the value is going to be 4. So you have to do a subtraction. So how to do that? So, and one more condition to be understood is that there can be only one preceding values before this V. It cannot be I and V. Okay, it will just be one value. For example, let's say it could be DM, for example. I'm not just saying it. So it would be, there is a larger value and this value is a smaller one. So you have to decrement the, let's say, 1000 by 500, which is going to be 500 only. It's a one way of writing it. So how to do that? And that would be a simple thing that we can do. So we can write a for loop. So for I in range 0 to length of our S for normal condition, right? And we're going to have a value called result, which is going to be 0. So if the I plus 1 is greater than length of S, so it is, if it's going outer bound, then just we do not need to process it. But and the S of I is less than S of I plus 1. So in this case, right, because S of I, right, this value is less than V, right? So in that case, what we are going to do, we are going to just decrement that value. So result minus equal to S of I, and we are going to store this S of I value to a hash map or a dictionary to get those corresponding, let's say V stands for 5 or whatever. And else we are just going to increment res plus equal to S of I. And that would be a simple formula change that we need to do for us to make it work. So now let us jump into the Python implementation of the given problem. Now let us quickly create the hash map. So let me type in the hash map. So I value is 1, V value is 5. So we are creating that hash map. Now we are going to have a variable called result, which is going to be initially 0. Now we are going to loop it. So for I in range 0 to length of S, and now for our condition, if I plus 1 is less than length of S and Roman, because we are checking the value, so Roman S of I is smaller than Roman S of I plus 1. In that case, we are going to decrement the result value by current Roman 1, else the result is going to get incremented by the current Roman value, and we have to return our result. So very simple problem. Let me click on running the public test cases. It ran perfectly. Let us submit it. And as you could see, the time complexity of it is going to be big O of n. So it's a very simple solution, because here, right, we're looping it only one time. There is one hashing function, but as you know, right, to find the key value pair is just take 1 unit of time, so not an issue. And as you could see, it is beating 43.58%. If I submit it again, more probably it will going to be higher. So, oh, it's got lower. But anyway, this is not a very perfect calculation. But anyway, that's all for this video. See you in the next one.